right, so these are the two we've done so far, so I just hit record, so I'm going to do a real quick recap of everything I just said. So this is the first one we did. This is the second one we did last week, right? Both of those are on your formula sheet, okay? The third one isn't on your formula sheet. You just need to know that when we don't have that sigma value, we can no longer use Z. We have to use a different critical value, which we call T. Okay? So the last one that we're going to talk about is X bar plus or minus T. And we're going to use T whenever what we have to use is the standard deviation of the sample. So if what you are given is the standard deviation of the population, you use Z. If what you are given is the standard deviation of the sample, you use T. Now, the general practice is not that different than what we've been working with, okay? Now, this is better. The first one we learned is better if you can do it. And the basic premise is when we have to use the standard deviation of the sample is not necessarily a good representation of the standard deviation of the population. So we don't want to use it unless we have to. Okay? All right. So to find this T, like we can't use inverse norm because it's not normal anymore. It follows this T distribution, which is very, very, very close to the distribution of Z's. Okay? All right. So T distributions, we'd have a center of 0, just like Z distributions. But the standard deviation of the T distribution kind of changes based on the sample size, okay? Larger samples, the T's are close to Z's. So we don't really describe them with a mean of 0 and a standard deviation of 1 because the standard deviation isn't 1. It's bigger than 1, okay? And how much bigger depends on my sample size. So instead, we describe them with what we call degrees of freedom, which we abbreviate DF. And the degrees of freedom is always your sample size minus 1. So let's say I want to find that T to be 95% confident when N equals 48. This is what that picture might look like. I'm going to describe the center as 0. I'm not going to describe the standard deviation. Instead, I'm going to say, how many degrees of freedom do we have? And how many degrees of freedom do we have here? 47. And if I want to be 95% confident, that means my middle area will be 0.95. What does that make my tail? 0.025. Do you guys see that this reasoning is almost identical to what we were doing before? Okay, now, I can't do inverse norm because I don't have a standard deviation, but I bet if you pretend to use inverse norm, you might see something you might be able to use. There's an inverse T, which asks you for an area. Which area are we going to give it? 0.025. Remember last week when I said that I wanted you guys to start practice finding that left-hand tail area? This is why. So you're going to put in 0.025 for the area. What's the next thing your calculator asks you for? DF. What are you going to put in for DF? 47. And which values of T are we ending up with? I'm sorry? It doesn't matter because of what in the same way with the Z's you ended up with negative, but we just made it because we end up plussing and minusing it in our margin of error anyway. Okay. you have to give it the tail area, not this side.
I know.
But this one, somehow this had answer times it, so it took whatever the previous answer was times the negative 2.012. Okay, can you guys try the next two for me?
It was 2 equal again?
2.1012.
No, like, what is it? Can you just scroll over?
We use t instead of z when we do our standard, or when we do our margin of error, if we don't know sigma. For the first one, 1.8?
Yeah.
1.80?
Yeah, it's like 1.795.
Okay.
And the next one's 2.921.
Okay. Okay, so as we read this, suppose newborn weights are normally distributed. We have a sample size of 16, so my n's going to be 16. And it reveals a mean weight of 7.2 and a standard deviation of 0.59. You guys, that standard deviation is, what is it describing? All newborn baby weights or the sample? Sample. So we need to recognize that this is an S, not a sigma. Okay? And the minute that I see that it's an S, that's telling me I have to do things slightly differently. Okay? Now what? Find our t value. What would my degrees of freedom be, by the way? 15. And what are we getting for t? 2.682? 02. Okay. And so that means I'll have 7.2 plus or minus that 2.602 times 0.59 over the square root of 16. Because it's not over the square root of the degrees of freedom, it's over the square root of the sample size. Okay, you guys. You'll notice if you do those tests that just like you had a Z interval and a T interval, right? So I can jump straight to the interval by choosing the T interval. In this case, we have the summary statistics. And we can just type in, well, what was my mean? 7.2. My standard deviation was 0.59. My sample size was 16. My confidence level was 0.98. And I have no problem with you jumping straight to, I have no problem whatsoever with you guys jumping straight to the interval, as long as you then understand how to find the margin of error from that interval. So, like, your work could just be what I have boxed here, because you can just put it directly into the calculator. There's other ways I'm going to ask you to figure out other stuff. Does that make sense? All right. What do I have? Do I have more examples on the back? So.
Oh yeah, there's one more.
There's one more? Okay. Let's do this one together and then... Okay. So, in this case we have the raw data, yes? So, I would hope by now you guys are getting to the place where whenever you get a list of numbers, what do you want to do? Put it in L1. So I'll do that, you do that. Okay. You guys. So, this will be a great example of, since eventually what we're doing is creating an interval, let's go ahead and just hit stat, arrow over to tests. Okay. Do I know the population standard deviation? Is that given to us at all? No. So the minute I don't know that population standard deviation, but we're dealing with means, that's what tells me I want to go with a T interval. So everybody select option number 8. And this time,
Why can't you just do it by hand?
let me show you this, and then you're going to be like, this is way easier than doing it by hand. You can. You do want to do it by hand? This is just going to give you the answer. Okay. Okay, so then what you would need to do is run the one variable stats to get X bar and the standard deviation. Okay. All right. So where it says frequency list, you want to leave that as a 1, and we have 0.92. Yeah? It'll stay at 1 unless you change it. Yep. Everybody good? I hit enter. All right. So, now the question is which of these things means which of these things, yes? Okay, so what is the point estimate for the mean?
70.286.
It's whatever X bar is. Construct the confidence interval and interpret. What's my interval?
68.
Okay, so that would get you the credit for construct. To interpret that, that's all you need to do. Okay. Now, that gives you the numerical answer. It doesn't give you the interpretation. We're going to say with 92% confident, we can say the actual mean height of all college-age men is between 68.585 inches and 71.986 inches. Yes, I will be picky about including units and context. So if you just say the real mean is somewhere in between those numbers, that won't be enough. Like when we're interpreting, we're trying to do it in the context of the question.
My answer was a little different. For B.
For B,
Yeah.
but not for A. A?
Yeah.
I guess is it's the level of.
Okay. Hey, you guys with some margin of error?
Would it be 70 plus or minus? Yeah.
Well, so here's what we know. 70.286 plus our margin of error gave us 71.986. Does that make sense?
One
1.70. And again, that would be in inches. Right. Okay, and then you should have some more practice problems if you need them. Okay, so I'm going to pass out the lab today because you have tons of time. It is my recommendation that you either work these practice problems or start the lab, okay? If you're not using statistics class to work on statistics, then you're making a big, big mistake. Everybody good? I did run copies of the lab. I just need to figure out where I set
Do you
them.
have any entire class tomorrow to the lab?
But you will not have, like, I'm bumping the Unit 8 notes to start on Thursday instead of where I have that. Because my intention is to try to maybe speed up a little bit and move those flex days to the 2 days before spring break when people may or may not be traveling and stuff.
Can you work on the homework?
Yeah, absolutely. You can just work on stats is my thing.
We're not gonna have a homework day, right?
To be honest, like, we'll see what happens this week. Let's see how fast we get through Unit 8, and then we're gonna make that call. Or, does that make sense? Yeah, if I remember right, this one goes pretty quick. I can't remember, there's 2 for Unit 8, and I can't remember if they go quick or not. I sent you enough of ideas, yes?
Yeah.